Hello. In this video, we're going to be solving quadratic equations by factoring. Before we start that, let's do a little bit of review. So first off, a quadratic equation is an equation of degree 2. So in other words, if you look down here, this is a quadratic expression. It's an expression because it doesn't have an equal sign. If we put this equal to something, like equals y, this is now a quadratic equation because it has degree 2 and it has an equal sign. By the way, degree 2, if you don't remember, means that the biggest exponent for your variable is 2. All right, so factoring out the GCF, you got to know what the GCF is. That's the greatest common factor. Okay, that means it's the biggest factor that all the things have. All right, so I'm going to be using factoring out the GCF when I factor a quadratic trinomial by grouping. Now, factoring by grouping is something you usually do whenever you have 4 terms, but I'm going to use it on a trinomial by splitting up the middle term into 2 different terms. That way, I'll have 4 terms to use. So let's do an example of this before we go on. So I'm going to factor this expression by grouping. So I make a table to kind of help me figure out how to split up that middle term. I take my first coefficient and multiply by the last number there, and I get -9. Now I'm going to look for my factors of 9 and list them down below it. Now this minus sign right here is what I'm going to do with my factors in order to get this middle term, which is 8. Now the reason why I put -9 here is because whenever I split this up, I want it to I want the factors to multiply together to give me -9. So my factors have to be opposite signs. All right, so factors of 9 are 1 and 9, and 3 and 3. Now, when I subtract 1 from 9, I get 8, so that's the one I'm going to use. If I subtract 3 from 3, I get 0. That's definitely not the same thing as 8, so I'm not going to use that. And really, if you take it one at a time, you can stop as soon as you know which one you're going to use. All right, so when I split this up, I have 3x squared. Then I'm going to have a 1x and a 9x, and then -3. Now, the 9 needs to be positive, because when I combine these two, I need to get positive 8x. So the regular x is going to be negative, so it's 3x squared minus x plus 9x minus 3 is what I get when I split up that middle term. So now I've got 4 terms I can factor by grouping. I group the first 2 and the last 2, and now I factor out the GCF out of each group. So the GCF of 3x squared and x is x. Okay, so when I factor it out, I get 3x minus 1. The GCF of 9x and 3 is 3, plus 3. And when I factor that out, 9x divided by 3 is 3x. -3 divided by 3 is -1. Now if you'll notice, the stuff inside the parentheses is the same. That's what we want. That means we can factor this, and I'm going to factor out the 3x minus 1. And what I get is 3x minus 1 and x plus 3. We just factored this trinomial by grouping. Now, you may be wondering, what does this have to do with solving a quadratic equation? Well, what we're going to do, well, here's what a quadratic equation is, just showing you the definition of it. And it can have 0, 1, or 2 real number solutions. I got a little bit ahead of myself. I apologize. All right, to figure out the solutions to a quadratic equation, you're going to follow these steps. We're going to solve this by factoring. And the way we're going to do that is we're going to use something called the zero product property. In order to use that, we have to first get one side equal to 0, and then factor the quadratic. After you factor, you use the zero product property, which once again is on the next slide. Once you use the zero product property, you're going to have 2 things that you're going to have. You're going to solve each part of that for the variable, and that way you get your answers. And of course, as always, you want to check your answer, make sure it makes sense, and make sure it works. So here's the zero product property. The zero product property is pretty simple. It's kind of one of those duh things. It says if two numbers are being multiplied together and you get 0, then at least one of the two numbers must be 0. So for example, if you have something times 2 and you get 0, you know that that something there has to be 0. If we've got uh, two binomials, so for example, let's say we've got 2y plus 4 and y minus 1, and that's equal to 0. Well, these two things right here, whenever you compute them, you just get a number. So that means that each part has to or could be 0. So either 2y plus 4 could be 0, or y minus 1 could be 0. And these two things are now linear equations, and we know how to solve those. All right, so let's see what the zero product property looks like in action. I'm going to solve this equation by factoring. So my first step is to get this, well, that should be an x instead of a c there. My first step is to get this equal to 0. And I do that by subtracting 3 from each side. So I get 3x squared plus 8x minus 3 is equal to 0. Now I picked this because it's the same thing that we did back here when we factored this. So we've already factored this before. We got 3x minus 1 and x minus 3. So when we factor this, we get 3x minus 1 and x minus 3. But now we're in an equation and it's equal to 0. And don't worry, if you want to see another example of factoring by grouping, I've got another example I'm going to do right after this one. Now that we have two things being multiplied together that give me 0, I can use my zero product property. So the zero product property says that either 3x minus 1 has to be 0, or x minus 3 has to be 0. So that's where we get our two answers from. If x makes this part 0, then it works, or if x makes this part 0, then it works. All right, so I'm going to solve for x now. I'm going to add 1 to both sides. So I get 3x is equal to 1, and I'm going to divide both sides by 3. And I get x is equal to 1/3. Or, on this one, I'm just going to add 3 to both sides, and I get x is equal to 3. So either x equals 1/3 or x equals 3. So if you plug this back in, it should work out. And if you plug this back in, it should work out. For the sake of time on the video, because I don't want you to have to watch a video for a 20-minute video, I'm going to skip the checking it part. You can do it using a calculator, or you can do it by hand, either way. I'm going to go on to the next example. So example 2. Here we have another equation. Let's see, I think there's supposed to be an x in here somewhere. Let me think. Yeah, this is supposed to be 2 minus 2x right there. All right. I don't know what it is with all the typos today. I apologize. But it's 2x squared minus 2x equals negative 4. Nope, it's not supposed to be that. Hold on. All right, sorry about that. Here's our new problem. We've got the previous one. I was going to teach two different ways to solve quadratics in the same video, and I decided against that, and I forgot to change the example. So here's our new problem. We've got 2x squared minus 12 equals 2x. All right, so my first step, I've got to get it equal to 0. So I do that by subtracting 2x from both sides. Now, when I do that, I want to make sure this side is in standard form. When I say standard form, I mean my degree goes from biggest to least. So we've got degree 2, and then degree 1, and then degree 0. All right, so now we've got it equal to 0, and now I need to factor this side right here. So I do that by making myself a little table. Actually, the very first step to factor this is I would factor out a GCF. So I'm going to factor out a 2. And so I get x squared minus x minus 6. All right, so now I'm going to make my table using this trinomial right here. Now, you may say, well, did I have to factor out the GCF? No, you didn't have to, but it does make things easier because my numbers are smaller. For example, this number right here now is a 1, and so I'm looking for factors of 6 instead of factors of 12. And I'm going to be subtracting, and I want to get negative 1. So uh, when I subtract, I want to get 1. All right, factors of 6 are 1 and 6. When I subtract, I get 5. That's not it. And 2 and 3. And their difference is 1, so that's what I want to use. So the 2, since this is a zero product property, I can go ahead and use it. I've got 2 times something, that gives me 0, so this something has to be 0. So x squared, and then the 3 needs to be negative, so minus 3x plus 2x minus 6 is 0. Now, I left off the 2. These two things aren't exactly the same, but they do have the same x values that make it true. Because obviously the 2 doesn't equal 0, so I'm just going to leave that off. Now I factor by grouping. All right, the GCF of x squared and negative 3x is x, so I get x minus 3. The GCF of 2x and 6 is 2, so I say plus 2, and I get x minus 3. So once again, stuff inside the parentheses is the same, so I take it to, I factor it out, so I get x minus 3 times x plus 2 is equal to 0. Now I'm going to use the zero product property again. I've got two things being multiplied together to give me 0. So either x minus 3 has to be 0, or x plus 2 has to be 0. Hold on just a second. Sorry about that. Pushed the wrong button. All right. So back to what we were doing. X minus 3 is equal to 0, or x plus 2 is equal to 0. Solving each one, I get x is equal to 3, or x is equal to 2. And both of those are answers. And so if we plug those back in to our original equation, 3 squared is 9, 9 times 2 is 18, 18 minus 12 is 6, 2 times 3 is 6, so that is true. Those two things are equal. If we plug in 2, 2 squared is 4, 4 times 2 is 8, 8 minus 12 is negative 4. Hold on, I'm supposed to subtract 2 from both sides. There we go. So that should be minus 2, or negative 2 instead of positive 2. I'm glad I checked my answer, and that's why you want to check your answer, to make sure you got the right answer at the end. All right, so negative 2 squared is 4, times 2 is 8, minus 12 is negative 4. 2 times negative 2 is also negative 4, so that works. So these are my two answers. All right, well, I hope this video helped. Make sure that you either post a question if you have a question on the video, or if you're in my class, come in class tomorrow with questions prepared, and have a good one.